Alright guys, so you're welcome to today's class. We'll be looking at Michealis-Menten equation. So Michealis-Menten equation is a major equation when it comes to general biochemistry and particularly enzymes, enzymology. Alright, so the Michealis-Menten equation helps to understand what we call enzyme kinetics. Alright, it was discovered in the year 1913 by two scientists who worked collectively to actually understand enzyme activity and enzyme kinetics. Their names were Michealis, and Menten. Alright, so these were their names. Alright, so I want you to first of all bear in mind that the Michealis-Menten equation is something that you can understand. Alright, so let's dive straight into it. Alright, so we'll start with an equation, and that equation we have E plus S, a reversible sign, where we have K1 at the top and K minus 1 at the bottom, which gives us ES. Alright, then another reversible sign with K2 at the top, E plus P. Are we together? Alright, so now what is your E? The E is your enzyme. S is called the substrate. Remember that when it comes to enzymes always bind with substrate in an active site to produce a biological response. Are we together? Yes. Alright. So then now ES is called enzyme substrate complex. Enzyme substrate complex. Now our K1 is called the rate constant or forward rate constant. It's called the forward rate constant. While K minus 1 is called the reverse rate constant. Alright? Then our K2 is rate constant for product formation. Rate constant for product formation, while our P is called the product. So bear this in mind. P is called the product. Now there are some other equations we need to also bear in mind. Now we have what we call the rate velocity or rate speed of the enzyme to bind to the substrate. And it is the product of your rate constant for product formation and the enzyme substrate complex concentration. Alright? Enzyme what? Enzyme substrate complex what? Concentration. That is your ES. I told you that anytime you have something in square bracket, it means what? Concentration. Now also have what we call Vmax. Okay? Vmax. Vmax is equal to your K2 multiplied by your total enzyme concentration. K2 times total what? Enzyme concentration. Alright? So now, we'll start with another expression. And that expression is K1 E times S equals to bracket open K minus 1 plus K2 times ES. Alright? K1 times E then S. This is your enzyme concentration, this is your substrate concentration, equals to K minus 1 plus K2 times your enzyme substrate complex concentration. Is that okay? Is that okay? Alright. So now, look at these guys. The next thing we have to do here is to make our enzyme substrate concentration subject of the formula. Make this guy subject of the formula. Okay? So how do we do that? We have to divide both sides by K minus 1 plus K2, right? So it means that to make this man here subject to a formula, okay? To make this man subject to a formula, we'll divide both sides by this man. Alright, so this will be equals to K1 E times what? S, right? Divided by K minus 1 plus what? K2. Divide both sides by K minus 1 plus K2, you have this. Alright? Then now there's what we call Km. Km is called the Michaelis constant. Km is called what? Michaelis constant. And Km is equals to K minus 1 plus K2 divided by K1. Km is K minus 1 plus K2 divided by K1. Okay? So what we have to do now is to introduce this guy. Substitute our Km here. So when we substitute our Km into this equation, we substitute this guy, Km. Km is K minus 1 plus K2 all over K1. Can you see K1? Can you see K1 over K minus 1 plus K2? But now, instead of Km to be at the top, because this is the inverse of what you're seeing here, Km will be down. Are you following? See, normally Km is K minus 1, that is the reverse rate constant plus the product rate constant divided by the forward rate constant, right? But now if you look at it here, we have K1 over K minus 1 plus K2. So now, for us to now substitute Km here, since this is the inverse of this, it means that to put this here, it will now be 1 over Km. Is it not? So it means that Km will be down. So it means that this is what we'll have. Our enzyme substrate complex concentration will be equals to our E S divided by what? Km. But mind you, let me give you the Michealis-Menten equation. All right. Okay. Let us, since we are already in process, let us finish it. Okay. Let us finish it. All right. So, okay, I can clean this. All right. Now, the next thing to do. Remember, I told you that V is equals to K2 ES, right? K2 ES, right? Now we also have what we call enzyme, total enzyme concentration, and the formula is concentration of E plus concentration of ES. Okay? Concentration of what? E plus what? Concentration of what? ES. So now, do you know the idea? The idea now is to make this guy solve a formula. So we can substitute into this equation. Make E solve a formula. This is the formula for total enzyme concentration. So make your enzyme concentration subject. Okay? Make your enzyme concentration subject of the formula. Alright? Here. So you can substitute it into this. Don't regard this yet. We'll use this later. But I just wrote this to remind you. Alright, we'll use that later. But now make it solve to a formula. So for E to be solved to a formula here, it means that our total enzyme concentration will now be minus what? Minus ES, right? This guy will come over, right? And it will become what? It will become minus, right? Good. So now what do we do now? We substitute here, this E into this. So it means that our ES will now be our total enzyme concentration minus what? Minus ES, right? Times what? S divided by what? Km. We substituted here for this. We remove E and replace it because E is equals to total enzyme concentration now, right? Minus ES, right? So what we did was that we substituted this guy for this guy. We took everything here. Look, E was supposed to be here now. E times S all over Km. Are you following? So what we have to do now is our ES will now be equals to, now we put this guy in brackets and expand. This will now be total enzyme concentration times S minus enzyme substrate complex concentration times what? S divided by what? Kn. Are we together?
Yes.
All right. Okay. So now, our aim now is to make ES subject to a formula. Okay? Make our ES subject to the formula. Let's resolve it such that we don't have more than, if you look at ES here, see ES here. Okay? So now, what we have to do is this, cross multiply. So now, we will now have ES times what? Kn. This will now be equals to, we can factor out. Is there anything common here? Is there anything common here? Alright, so what is common? S, right? Okay, so if we factor out S, okay, here now we can have something like this. You can say ET, okay, ET, but okay, now let's look at this. Let us move this guy first. Let's move this guy first. Alright, so now this will be, when we cross multiply, this will be ET S minus ES what? S. Alright, minus ESS. We have cross multiplied. Right? So let's collect like terms. Let's collect like terms. So this will be ES KN plus ES S, right? Equal to ETS, right? Are you following? So we can factor out here now. We can factor out ES here. So when we factor out ES, we will now be left with KN plus what? Plus S. Is that correct? Equals to ETS. So can we make ES subject to a formula now? So ES now, if ES is made subject to a formula, we divide both sides by KN plus S, right? So divide both sides by this guy. So this will now be ETS divided by KM plus what? S. KM plus S. Now, it is now that we will now use this formula, right? So now, recall that V is equals to K2 times ES, right? Okay. K2 times ES, right? Hope you know that everything here is ES. So carry this guy here and put inside this ES. Carry this guy here and put here. Okay? Substitute everything here. Put it in ES. So now it means that you now have V to be equals to K2 brackets E what? T times S divided by Km plus your substrate concentration. Alright, so now look at this guy. So V is equals to K2 times this. So now recall that V max is equals to K2 ET, right? K2 ET. Is it not? Is it not? Good. V max is K2 ET. So look at K2 ET here. Right? Are you seeing it? So it means that we can say V is equals to V max times what? S divided by Kn plus S. This is the Michealis-Menten equation. Alright, so if you're watching us, any country you are, alright, you have any question whatsoever, as if you not subscribe, hit the subscribe button, okay, like this video, share it to your friends abroad, and see you in the next class.